Hey guys, today we're going to work on system of linear and quadratic equations. So for this nuke again that says the accompanying graph illustrates the presence of certain strains of bacteria at various pH levels. So we see that we have a graph here. Alright, so the question says, what is the range of this set of data? So when we're talking about range, we need to know what range means. Range is talking about the y values. Okay, domain is x, range is y. So we're looking at the y values. We're looking at this axis right here, the vertical axis. So that's y, and this is x. I'm just going to label those so we know. So as you can see, the point starts here. It says 5 and 9, but that's the x-axis. So anything with 5 and 9, we're not looking at. That doesn't make sense. All right, so let's actually take a look at, and again, also, since we're talking about y values, it can't be answer choice 2 either, because as you can see, these two here are talking about x. Doesn't make sense. So they want to figure out what's the lowest point and what's the highest point. What I like to do, I like to draw a line, and we can see exactly what we're talking about here. So I'm going to grab this line, and we want to see what's the lowest point. So the lowest point is going to be right here. It's not that point over there, it's this point right here. And that's right in between 0 and 10. So between 0 and 10 is 5. It's not 0, so I can cross out answer choice 3 right away. And it seems like it's answer choice 4, but let's continue checking. I found the lowest point. Let's find the highest point now. So I take the same line and I drag it all the way up. Oh, the line, there we go. And drag it all the way up. I see that this is the highest point right over here. And the highest point for this graph is 70. So this is telling us that our graph for the y-axis, the range, is from 5, that's the lowest point, all the way up to 70, which is the highest point. So it's answer choice 4. That's just something that, it's more of a review that we've done before. Okay, so today we're going to talk about system of equations. Now we've dealt with system of equations before. It's where we have two or more equations. So you guys have seen something like, for example, we have 2x plus 3y equals 10, and 5x minus 3y equals 7. So we've seen something like this where we can use elimination, substitution, or graphing in order to solve these problems. Now, whenever we talk about the solution, it's where these two lines intersect. That's our solution point. But we can also have one linear equation and one quadratic equation. Now, a linear equation, this is just a line. And for a quadratic equation, that's a parabola. That's just a fancy word for the U-shaped graph. So it looks like this. Okay. And there are different types of solutions. Now, we have this parabola and we have a line. There are two intersection points here. There's one right here. It crosses at that point and it crosses at this point. So since there are two intersection points, that means that there are two solutions. It's possible to have only one intersection point. As you can see, this line barely touches this parabola. Right there at that point. So since there's one intersection point, it means that there is one solution. Now it's also completely possible that you have a parabola and a line and they don't intersect at all. So since there are 0 intersection points, there's no solution. You can write no solution or 0 solution. Generally you'd write no solution for this. Okay, because it doesn't cross at all and there can't be a solution possible. Okay. So let's solve these system of equations. So what we need to do is that we need to graph both of these equations and figure out where they intersect. We have this graph here, so we're going to use it. So the first step says, let's graph the first equation, right here. In order to do that, I'm going to use my calculator. I go to y equals, and I type in this equation. X squared plus 4x minus 2. So if I want to look at the graph, my graph here should look something like this, where we have that U shape. But again, we're going to look at the table. Now, graphing quadratics, we want to get numbers where it repeats on both sides. So as you can see, if we go all the way down, these numbers gets bigger and bigger and bigger, there's no way that it's gonna start to repeat. So we're gonna scroll up instead. So I have -5, that doesn't repeat. I have -6, that doesn't repeat. And then -5, that starts to repeat. I'm gonna keep going until I see everything repeats. So the 10 repeats, 19 repeats, and that's it. Let's say I have a 19 here and a 19 here. Now for your calculator, you're not gonna have all of these points, remember. It's probably gonna be from like -4 to 0. But if you have it like this, you can write them all out. Once you have where the points repeat, you know that you're good. So I have my x and y. I'm just going to graph a couple of points, not all of these. So I'm going to start at -5, 3. So we have -5, comma 3. We have -4, comma 2. -3, comma, oops, not 2, it's -2. So -3, -5. -2, -6, -1, -5, 0, -2, and finally 1, comma 3. Alright, so this is for the first equation, this one right here. I'm going to graph it in green. So I have -5, comma 3, -5, 1, 2, 3, 4, 5, 3, 1, 2, 3. I have -4, -2, -3, -5, 2, 3, 4, 5, and 6, and then it starts to repeat. Okay, so here we have our graph. I'm going to try my best to connect this as nicely as possible. Alright, good enough. Remember, we're going to put arrows because this continues on forever. Okay, if we wanted to, we could have plotted the last point. So it goes to -6, 10, which is over here, and to 10, right here, because it fits on the graph. So I'm just going to do that. I'm going to graph all the way to here. And get rid of these arrows. So I'll just plot these extra points, and I'm going to make the U shape one more time. Alright, that one was a lot better. Now we're going to graph the second equation. For the second equation, I'm going to graph it in red, but there's an issue. As of right now, I need to get this in y equals in order to graph it, but I don't have that yet. So I'm going to do that right now. I have y minus 1 equals 2x. To get y by itself, I add 1 on both sides. And I have y equals 2x plus 1. Now, I prefer to graph this without using the calculator, but I'm going to type it in just so you can see the table as well. So I'll clear this out. I have 2x plus 1. And then second graph. So I have my table here. Again, I don't need many points, so I'm not going to use as many points. However, I'm going to start with, let's see, x and y. I can start with -5 because that fits, and I can go all the way up to 9. So, sorry, it's from -5 to 4. So I have -5, -4, -3, -2, -1, 0, 1, 2, 3, and 4. So I have -9, -7, -5, -3, -1, 1, 3, 5, 7, 9. Okay. Now I did say that I don't really like using the calculator. I like to graph it on my own. If you didn't want to write down this table, what you could do is use the y-intercept and use the slope. So my y-intercept here is 1. So I know my first point will be at 1. And my slope is 2. That's the same thing as 2 over 1. And this is rise over run. So I'm going to go up 2 over 1. As you can see, there's one point that is already shared. I'm going to continue. Up 2 over 1, up 2 over 1, up 2 over 1. Okay? Now, I have one solution here, right? And I have all of these points. Am I good? Not really. I need to go to the opposite direction again because this line goes in both directions. So instead of going up 2 and over 1, this is the same thing as going down 2 and to the left 1. Okay? So down 2, 1, 2, to the left 1. And I'm going to continue this pattern. As you can see, I'm using the same points that are on this graph right here on the table. And I have my second intersection point there. I can stop, but I'm going to just go one more. And I have this line here. I'm going to use this tool to make it as neat as possible. Okay, so I start from here, and I go all the way down to here. Here we go. And again, since this is a line, I'm going to draw my arrows because it goes forever in both directions. So I have two solution points. Okay. The first solution point is up here. I'm going to highlight it in blue so you can see it. This is my first intersection point. This is my second intersection point. So for the first one, this point here is 1, 3. So 1, 3. And for this solution, it is -3, -5. So I'm going to label this one as -3, -5. And these are my two solutions right here. So you can even write it out as the solution is 1, 3 and -3, -5. Okay? And that's how we find it using the graph. Now, we wrote out the table. We took all of the steps in order to write out this table. We can also compare the two tables and see where they intersect as well. So if I look here, I look at -5 and -5. They don't have the same y value. -4, -2, we have -4, -7. That doesn't work. -3, -5, -3, -5. There's our first solution right here based off of the table. And that's what we found right here. So I'm going to circle this one as well. And I continue looking. This one doesn't work. This one doesn't work. 0 doesn't work. But 1, 3, that definitely works. They're both the same in the table. So you can also compare the table to see which ones are your solutions. Now with that said, there's an easier way without showing any work. The reason why we show you the work is that when you take the regions, if you take the regions, for a short response, you may have to graph it here and then show where the intersection points are. But if it's just a multiple choice question, you can follow these calculator steps. So the calculator step says type in the first equation into y1, second equation into y2, and click graph. For now, I'm going to do it with this problem here. So I'm going to type in the first equation. We had x squared plus 4x minus 2. And we're going to type in the second equation into y2. The second equation was 2x plus 1. So we have both of our equations. And then it says to click graph. As you can see, this is the same drawing that we have over here, except this one's a little bit nicer. Now, in order to figure out where they intersect, from steps 4 to 6, we can do all of that on the calculator. You're going to press second and trace this button right here. We're going to calculate something. So we want to calculate where they intersect, so we're going to choose 5. You can scroll down or just press 5. And then you're going to click enter 3 times. Now, in order to get your points, as you can see, there are 2 points here. We want to move as close as we can to the intersection point. So the cursor is right by where the intersection is. So I'm going to press enter 3 times now. 1, 2, 3. And it gives us our first intersection point. It says x is 1, y is 3. And there's our first point, 1, 3. To get the second point, I'm going to do the same thing. So steps 4 through 6, I'm going to do again. So I press second, trace. I want to calculate the intersection, so I press 5. And now I want to go down to the other intersection point. I scroll my cursor all the way over to this side. It doesn't have to be exact. It could be a little bit off like here. As long as you're closer to that intersection point, you press enter 3 times. And there's our second intersection. -3, -5. So for here, -3, -5. And that's the easy way to do it on the calculator. Now, if you're required to show work, or if you have to graph it, you're going to want to do it this way. Okay? And remember, whenever you don't have it in y equals, always get into y equals form. Okay, so as you can see, this one here, it gives us a graph, so it seems like we need to graph, but let's try using that shortcut first. So we have two equations here, and we need to put it into y equals because neither of them says y equals. I'll do the first one on the side here. We have y plus 5x equals x squared plus 3. I need to get rid of 5x, so subtract 5x on both sides. And I have y equals. Now, I do want to write this in standard form. This -5x cannot be combined with x squared or with 3. So instead, x squared is going to come first. Then our x comes second, so -5x. And then plus 3. For these types of problems, though, if you had put the -5x at the end, it wouldn't matter as much. But just for consistency, we would like to keep it like this. So that's the first equation. Second equation is y plus 6 equals x. And I subtract 6 on both sides. So we have y equals x minus 6. Alright, without even using the graph, we can find out our solutions by using the calculator. So let's do that now. I go to y equals and I clear everything out. I type in the first equation into y1, which is x squared minus 5x plus 3. And the second equation, I type in x minus 6. It's my bird making noise. Sorry about that. Okay, I press graph. As you can see, how many points do we have here? It looks like it's just one point of intersection that we're going to use here. So let's calculate it. Hey, shh. Okay, so hang on one second. Okay, so in order to calculate it, we press second, trace, and we're going to press 5. Again, I want to go closer to my intersection point, so I scroll all the way over, and then press enter 3 times. 1, 2, 3. And there's our intersection point. Now notice, it's very, very weird. It's telling us that x is equal to 3.000011, and y is equal to negative 2.9999999. Don't let that fool you. The calculator is trying to do some math in order to find that intersection point, but it doesn't do it very effectively all the time. Essentially, we're going to round these numbers, okay? And they're going to give us our exact answer. So I'm going to write my answer in red. My x value is actually, instead of 3.00000001, it's just 3. And for our y, we have negative 2.99999. That's the same thing as negative 3. And that should be my answer. Okay? If I look at the table, I can also look at the table and see where these points are shared. So I press second graph, and I want to see where the y values are exactly the same. So for -5, all of these, they're not the same. But right here at -3, as you can see, we have -3 for both of the tables there. So that's also our intersection point. Now, we're just going to do it the long way because we do have a graph here. We're going to graph these two equations. Okay? So in order to do that, I'm going to get rid of this second equation. And I'll focus on the first one. So again, I want to see where these points repeat. I can see that they almost start to repeat here. I'm going to scroll down just a little bit more. And there we go. So it doesn't repeat nicely. As you can see, something's missing here. There's a point in the middle that's technically missing. We don't have it there. And that's why these will never line up. But it's good enough. We're going to use this to help us out. Okay? So I'm going to create an XY table for the first one. Since I used blue for the first one, I'm going to use blue again. Now we have X and Y. The first point that I'm going to use is, let's say 3. I don't have to use 9. I'll use 3. So, I'll use 9. Alright, so -1, 9, 0, 3. 1, -1. 2, -3. 3, -3. 4, -1. And wait, did I skip one? No, I'm good. 4, -1, 5, 3, and 6, 9. Okay, so I'll plot these points now. We have -1, 9, 0, 3, 1, -1, 2, -3. We also have 3, -3, so right here. 4, -1, 5, 3, and 6, 9. Okay. And I draw my line. Now, something interesting. Let me get rid of that line really quick. As you can see, we don't just draw a straight line across to connect these two dots. It's a U shape, so it has to continue a little bit lower than this point right here, and then curve its way back up. And I go up to the top. Oh boy. Alright, good enough. Nah, I'm not happy with that. Let's fix that. So I'm going to go down, and around, and back up again. It's very hard writing on a computer. Okay, that looks a lot better. And then I'm going to graph my second equation. So I go to y equals, clear this out, and I have x minus 6. X minus 6, and I get a table. Again, I don't really like using the table. I prefer to graph it by hand, so I'm going to do that. I'm going to start with my y-intercept. My y-intercept for this one is -6. 1, 2, 3, 4, 5, 6, right here. And I'm going to use my slope. My slope is 1, because the number in front of x is 1. So that means I'm going to go up 1, over 1. So it's going to look like this. Up 1, over 1. And there's our point of intersection. As you can see, there's only one point of intersection here. If I want to go down, I could go down, but the graph doesn't really go there, so I don't have to. You can if you want to, though. And then I want to make this neat, so I'll connect these dots here. Okay. And I go straight down to here. And put arrows on here because remember this is still a line and it goes on forever and ever. And as you can see here, we only have that one intersection point. It wasn't that crazy number that they were giving us, 3.00011. It's 3. And the other one, it's not -2.999, it's -3. So my solution point right here is 3, -3. Okay? So now you have multiple ways of doing this. You can use the table and compare. You can graph it and see where that point crosses. Or you can use the trace function using these steps here. I'm going to leave this up for a little bit longer in case you need to copy it. Also, what you can do you can just pause the video and write them down. It's very helpful to use these calculator steps when you're taking a test, especially multiple choice questions. Remember Daisy? She wants to teach math as well. Okay, and here are the practice problems. So you're going to work on 4 of these problems. Now notice there isn't a graph associated with it. Well, yeah, I guess there is. If you have graph paper, you can show it graphically. But we just need to see some work. What we want to see is that you're turning into y equals, and you're finding the solution. However you find the solution, if you did it with the calculator, explain what you did with the calculator. If you did it by the graph, take a picture of the graph so we can see it. If you use the table, write down the table, and then show us where the points are the same. Okay? Alright guys, hope you guys are having a great day. I'll see you all next time.